Unit 4. Monolithic reinforced concrete slabs. Monolithic reinforced concrete slabs. Monolithic reinforced concrete slabs are custom-made structures, cast on site, based on detailed structural designs, to ensure that the reinforcement's dimensions and distribution, also the slab's thickness, meet the required load-bearing requirements at all points. Monolithic reinforced concrete slabs may be flat slabs, ribbed, upstand or downstand or coffered at the top, slabs or two-way slabs. Flat reinforced concrete slabs. Flat slabs are flat structures, typically 15 to 25 centimeters thick. The slabs can be load-bearing in one or two directions. One-way load-bearing slabs may cover rooms that have a shorter span, 2.5 to 4 meters. The main bars are placed in the shorter direction, while the longer direction is used only for distribution bars. The long side is primarily used for load carrying, but typically a ring beam is made on the short side too. In the case of bidirectional load bearing, larger spans, 4 to 10 meters, have main iron inserts placed in both directions, with a primary load bearing requirement for each wall. Ribbed reinforced concrete slabs. In the case of ribbed reinforced concrete slabs, the flat slabs are reinforced with beams to carry the loads, while the plates act as load distributors. This is reflected in the slab thickness. The minimum thickness of ribbed reinforced concrete slabs is only 6 to 8 centimeters. Downstand reinforced concrete slabs. Here, the ribs are located at the bottom of the slab. Together with the ring beam, they require a complex geometrical formwork, allowing to make the reinforcement and carrying out the concreting in one step. The density of ribs may vary. Often, stronger beams, 15 to 40 centimeters high, 15 to 20 centimeters wide, are placed at an axis spacing of between 1.5 to 2.5 meters. In the case of a reinforced concrete slab with dense ribs, the axis spacing is only 50 to 60 centimeters, and the width of the ribs is a maximum of 12 centimeters. The upper level can be used for the floor, and the lower ribs can be used to install mechanical ducting. According to the requirement, the lower ribs can be left exposed or concealed by a false ceiling. Upstand reinforced concrete slabs. For an upstand slab, the ribs are positioned on top of the slab. The load-bearing capacity of such a slab is significantly lower than that of the upstand version. Formwork is not easy to build. Although the space between the ribs can be filled with larger mechanical ducting, a false floor must be installed or the voids filled to create the floor level. Waffle reinforced concrete slab. C2-M3-L4. Waffle slab is a network of perpendicular ribs. When installing formwork, plastic exclusion elements are inserted which can create coffers opened from below or closed with hidden cavities within the slab. Three mushroom flat slabs. Mushroom flat slabs are flat, reinforced concrete slabs with two-way load-bearing and point-like concentrated supports. The connection of the pillars is achieved by means of a cone-like mushroom capital. The slab thickness is at least 15 centimeters due to the two-way main iron inserts and the reinforcing iron around the supports. The more modern versions of the mushroom flat slabs have hidden capitals, creating a completely flat plate on the entire top and bottom sides of the slab. This further increases the required slab thickness, as the anti-punching shear reinforcement must be completely hidden in the slab. With respect to the challenges of reinforcement installation, this is the most practical, monolithic, reinforced concrete slab from an aesthetic, serviceability, and formwork point of view. 2. Modern execution of monolithic, reinforced concrete slabs. The 4 important steps in the construction process are formwork, reinforcement, concreting, and removal of the formwork. Formwork. In modern practice, we use large formwork sheets with timber beams which allow the formwork to be assembled quickly. 1. First, position and adjust the 3-legged, drop-headed floor props to the desired height. 2. Next, insert the primary beams. 3. After that, position the cross beams. 4. Finally, place the formwork sheets. The formwork of the associated structures, such as beams, stairs, and others, is connected to the large slab system, either by using the elements of the same system or by applying a custom-made traditional formwork. Installation of reinforcement. 1. Start with placing the main rebars for the base. 2. Distribute the reinforcement of the base. 3. Fasten 2-way irons together with tie wires to create a mesh reinforcement. 4. Position the mesh and place spacers to create the required base concrete cover. 5. For ring beams, position and fix in the following order: the bottom longitudinal bars, the stirrups, and then the upper longitudinal bars. 6. For the top part, place top distribution bars on top of the ring beam bars. 7. Then, distribute the main rebars at the top. 8. Finally, form the top mesh by connecting the main and distribution bars with tie wires. Concreting. 1. Before starting, the structural engineer checks the reinforcement and the formwork alignment, and also its penetrations, e.g. water pipe. 2. Mark the top level of the concrete on the inside of the ring beam formwork. 3. Pour concrete with a concrete pump from a mixer truck, preferably uninterrupted, in one single pour. 4. Work the concrete by hand to spread, compact and smooth, removing the formwork. 1. Keep the hardening concrete moist and watered. 2. After a few days, when the slab is sufficiently solid, remove the intermediate supports and the floor props. 3. Lower the primary beams with the drop heads and remove the cross beams. 4. Remove the primary beams and part of the formwork, leaving only the props in place. 5. Once the concrete is fully hardened, remove the entire formwork, including all the prop supports.